Josep Lluís is going to tell us about the concept of the notion of embluement, an expanded perception of the ocean, with his presentation, Embluement, Searching Enactive Interfaces for Participating in the Living Planet. So please welcome Josep Lluís Pelegrí.
Well, thank you so much, Elena. It's a real pleasure to be here. It's a great opportunity learning all the things that are being done in this wonderful joint experience of arts and science that we've been talking today. You know, the Institute of Marine Sciences, as Elena was saying, it's an excellent research center. It holds an accreditation, Severo Ochoa accreditation, which is the highest accreditation in the Spanish research level. And we are really committed to excellence in research, as well as to promoting and talent, youth talent. But also for the last, I would say, many years, but particularly the last 5 years, we've been very much committed to society with this motto that Anne-Marie was telling us this morning. It's the decade of ocean science for sustainable development. The emphasis is on the development. Science by itself is wonderful, but unless it has this purpose, this transformative purpose, it makes not much sense. So today I'll try to first review a little bit the role of the ocean on this planetary organism. Then I'll talk a few words about global change. This is probably things that you already know, but it's worthwhile underscoring them and saying what's really happening. And then a little bit of reflections on the sort of ways that we can engage people to change their relation with the ocean. And this probably is a possibility for Homo sapiens itself evolve as a species. The ocean, first of all, it's an extraordinary regulator. As was said this morning, it holds most of the properties that participate in the metabolism of the living Earth. Not only water, but also nutrients, carbon, or even oxygen. There's more oxygen than in the ocean than in the atmosphere. And it's a natural driver of climate change. It really, the climate we experience at the surface of the Earth is really driven by the ocean, the way that the ocean exchanges waters between the surface and the deep waters, the way this exchange has changed in the past. It's been sometimes swift, some other times it's been slow. And also it's regulating the anthropogenic effect. It's about, as we said this morning, 1/3 of the anthropogenic carbon dioxide, it's gone into the ocean. And over 90% of the anthropogenic heat that the Earth has incorporated, it's stored in the oceans. And this happens despite the increase of the average temperature of the entire water column. It's been about 0.1 degrees only. This is, of course, the surface layers have increased more their temperature because they are in contact with the atmosphere, but the average increase of temperature of the water column has been very small as compared with the increase that we have experienced from the pre-industrial periods. And well, this water cycle, I think, also is very interesting because I think I'll mention it later. But about 1/3 of the precipitation that we experience over Earth is really water that excess evaporation water from the ocean. So water is the essential and central mechanism of life, okay? And the only one that we know here in our planet and everywhere else in the universe. But water not only holds the metabolic state of the ocean, which is the basic metabolic state of the Earth, but also transfers to the Earth, to the lithospheres, so that the Earth is sustaining the way that we know. I here have two movies. Okay, these are just videos of the temperature of the surface of the Earth and the color, without clouds, of course, of the surface of the Earth, which reflects pigments, which essentially tells us the primary production. What we were saying this morning, that half of the oxygen we breathe comes from the oceans. That's the fact. And also what we see basically is the ocean pulsating, breathing, no? And every year at high latitudes in every hemisphere, pulsating, starting the entire cycle of waters at the surface layers, the top 1,000 meters, but also going deep into deep layers, and bringing up two cycles. One, it will be the pulmonary cycle. In our living being, it's a way of exchanging gases between the ocean and the atmosphere, and the other will be the metabolic, the basal cycle, where nutrients are continuously regenerated. No? And it's estimated that about 95% of the metabolic activity of our planet holds in the oceans. So that's when we talk about a living planet, we certainly have to keep in mind the ocean. No? And also, it's not only regulated, but it's also a great connector. It obviously connects all parts of the ocean itself, that extends worldwide, but also connects through the atmosphere, connects oceans with the lithosphere, no? Through the hydrological cycle. So when we look at the structure of the ocean, this is a mean snapshot, or maybe I recall now, but probably this is mean, but we see that there are regions that are very poor in pigments. These are the desertic regions of the ocean, but there are regions that are very, very high in pigments, no? And so the ocean, from top, we see that it's also composed by different regions. And when we look at sections, for example, here we have a section running from the subpolar North Atlantic to the subpolar, to the Antarctic Ocean, going north, and we look at it laterally, so that will be 6,000 meters depth, and this goes from 50 south to 60 north. We start to think that it has a structure. It has a structure as any living being. It has different regions which hold different temperature, different nitrates, different oxygen, different salinities, different properties, so that each subsystem has different roles in the complexity that arises of a structure and harmonic system, like each of us is. No? The wonder is that each of us works as an harmonic being in a homeostatic and a sort of equilibrium, dynamic equilibrium. This is the wonder. This is what is magic. But it's a natural evolution that it comes from the natural evolution of the Earth. No? So here we have also a top view, but in this case, it's a top view, not exactly the surface of the Earth, but at some constant density. This constant density here is at the surface, but here is several hundred meters deep. This is because this is a natural way, because water, as it moves, it keeps its density. So these are the natural pathways for water in the ocean, no? In a way. So we again see different regions with different properties that bring about this idea of a great connector with many subsystems that engage and complement each other, bringing up this planetary complexity. No? So it's interesting, from my point of view, is like any living being, in this case the most complex and most self-contained and auto-regulating organism that we know, the planet, is that it's got different scales. It goes from scales that run worldwide, like the global conveyor belt, and also scales that run at the transoceanic gyres. This will be the top 1,000 meters of the ocean. The other ones were going down to the deep ocean. But also when you start, well, let's look at this video for a second, just to have a glimpse of this planetary. Well, this will be a video showing how revolving the Earth and showing how this progresses, but apparently it's not. Never mind. So as we move, the idea of this video was that we were able to then start looking zooming at different regions, of the planet, but these are some snapshots. This is the Arabian Sea, for example, where we start to, these are again color pictures, where we start to see not only regional patterns, but also we start to see what we call mesoscale patterns. And if we go in here inside, we start to see submesoscale patterns. And then going further, we still see eddies that are smaller and smaller. And this is what is called the cascade of energy. And this goes all the way down to scales that are of the order of millimeters or a few centimeters. It's what is called the Kolmogorov scale. If you go, try to go, these are the smallest eddies that you can have in the ocean. You have to imagine the ocean composed by eddies that go all the way from global scale down to smaller and smaller scales, but down to these eddies of order 1 centimeter. Beyond this, there are no eddies. It's like when you look at something at the microscope, you see that there's everything laminar, everything is smooth, it's like calm. So these individuals, these virus, this phytoplankton, all these individuals that live in a bubble of the order of 1 centimeter diameter are living in some sort of placid environment. This placid environment lasts only for perhaps a second or a fraction of a second. But nevertheless, for a living being whose life is only 1 day long or a few hours long, this is like today for us. It's an entire day. No? So this is where the real metabolic activity of the Earth is taking place at these scales during very tiny fractions of time. No? It's like what's happening inside of us. Our life takes place at cellular scales in tiny fractions of time again. No? So this is, and even inside these bubbles, you still have smaller scales where properties diffuse, have time to diffusing. But this is a little bit sort of a cellular view of the planetary organism. No? So to me, it's very attractive. Okay, so second step is global change. Okay, what this natural system, it's been evolving and changing naturally always towards complexity, increased complexity from an Earth that was lifeless and then started being chemiosynthetic and then eventually photosynthetic, and every time more and more organisms and more and more biodiversity. Now, and during this period of time, the Earth has also experienced many mass extinctions, or at least 5 of them that we know. No? But right now, we are undergoing a different anthropogenically driven extinction or global change. Global change has two facets. One of them is degradation of natural ecosystems, and the other one is climate change. Just a few words about degradation of natural ecosystems. This is affecting really the quality of the marine and coastal ecosystems, as we said, is the essential element in the metabolism of the Earth, and is leading to an extraordinary loss of biodiversity. I'll talk about that in a second. But also it's affecting the quality of life of people. This morning we mentioned about anxiety. It's totally true. You mentioned about it. But also there's this, not only young people is having this anxiety of what's going to happen in the future, but also we are also each of us is accelerating every time more and more, and this is this loss of solastalgia, no? This a little bit, it's not the same, but it's related to this eco-anxiety. Biodiversity, okay, the human population, it's occupying this small compartment of the entire biomass in terms of carbon of all species on Earth. And despite so, is the one that is having a larger impact on the metabolism of the Earth as we know it. No? And this is driving a very, very large mass extinction. About 10% of all existing species, that's about 1 million species. It's estimated that there are 10 million species on Earth are at this time in risk of extinction. No? And there are these concepts of overexploitation of our Earth. We know that every time more and more the Earth overshoot day is anticipating, and right now by sometimes like July, it's already we have already exploited all the resources of the Earth that are available to us at the pace that we use them. But this usage is different depending on the country. There are countries like US or North America and Europe as well that its usage is much above what the resources are. That should be one. But there are other countries like Africa that are using much less than the available resources. No? So the idea here is that let's look at it as an opportunity. Okay, rather than seeing the danger, let's think, okay, this might be an opportunity, because for the first time in the history of humankind, we are realizing that we are overexploiting a finite planet. Till now, possibly, we never realized that this planet is finite, and we neither realized that we were overexploiting it. So I'll come back to this later. Just a few words about climate change. This is the second aspect of global change. Here, basically, we are receiving 340 watts per square. Per square meter. We are receiving 340 watts per square meter from the sun. About 100 watts per square meter are reflected automatically from the clouds and the surface of the Earth. They are not incorporated in the Earth system. And the other 240 are incorporated. They warm the Earth, and the warm Earth emits those. Okay, that's natural. But the Earth has some atmosphere that acts as a greenhouse. So some of these, don't worry about this, about the equations. They are very simple. What I want to emphasize here is that this is, I should spend some time that I don't have, but this is everything is radiative. You have radiation coming in, radiation reflected, the radiation that crosses the atmosphere, warms the planet, and then the planet irradiates back. The irradiation back warms the atmosphere, and the atmosphere, as it warms, radiates half of it outwards and half of it back to the Earth. The fraction that it's warming the surface of the air, the atmosphere, it relates to this gamma factor, which is the greenhouse gases. In the pre-industrial times, this basically tells us that 37.5% of the radiation of the Earth was absorbed by the atmosphere. So half of it went back to the Earth. So the Earth had to warm a little bit further to get rid of that excess of radiation because of the greenhouse. Right now, a couple of years ago, it went to 38.8%. And the pace that we are increasing greenhouse gases, this is going to increase to 40 or 41% by the end of the century, depending on how much fuel we are going to be using. And this is going to bring that pre-industrially we had a mean temperature of the Earth of 13.8 degrees. Right now it's about 15. It's increased 1.2 degrees from pre-industrial times, and it's going to increase several additional degrees depending again on this Earth scenario. No? Greenhouse gases, the main greenhouse gases, look at this figure. This figure tells us from pre-industrial times till today. And here we have watts per square meter. This goes from -4 to up to 2. You see, the effect of the carbon dioxide is this line here, tells us how this radiative balance that I just explained a second ago is being affected by the fact that we have more carbon dioxide in the atmosphere. So because of the presence of additional carbon dioxide induced by anthropogenically, we have rather than the 240 watts per square meter that I just mentioned a second ago, we have 242.5 square meters. I'm sorry again. So we have 2.5 watts per square meter additional because of this carbon dioxide, because of this presence of this greenhouse. There is also a little bit about 0.5 or 0.7 from methane, from nitrous oxide, etc. Carbon dioxide mainly comes from use of fuels, from fossil fuels. Methane, on the other hand, comes from agricultural usage. So everything adds up, no? Everything adding up, you have this black line. In these black lines, you have some spikes going down, which basically tells us that there was a reduction on the amount of radiation that was arriving to the Earth. And this was related to volcanic eruptions. Every time you have a volcanic eruption, you have many aerosols going into the atmosphere, and that reflects the energy of the sun. And also, we had this effect here that was because at some point we were using very much carbon as a fuel, and carbon also emitted aerosols. But this had a very large impact on the health. So we were removing carbon, but now again we are using more carbon because of this energy crisis. But the interesting thing here is that this change in carbon dioxide is basically the main factor driving this climate change, this greenhouse effect. And this you can see here on the right, you can see the temperature of the Earth, how it has evolved from 60 million years ago here until 10 million years ago, then during the last million years, and during the last 20,000 years. We see that the temperature of the Earth 40 or 50 million years ago was much warmer, and then went down. This is relative to pre-industrial times, to year 1800. So it was much warmer, then it's been oscillating between glacial and interglacial periods, and now we were here at present, we were at a peak of interglacial period, a period that is naturally warm for the Earth, and we were starting to cool down a little bit, going slowly into a glacial period that would have lasted for 80,000 years. But because of the effect of anthropogenic effect, because of all this carbon dioxide and other greenhouse gases that are introducing in the atmosphere, it's going up. It's drastically going up. And this is basically reflected, all this pattern basically copies the pattern of CO2 concentrations, all this, and right now we are here increasing the amount of CO2 in the atmosphere, and that's going to be driving this increase. This is only the last years, okay? So, and what's going to happen in the future? In the future is going to happen depending on the amount of gases that we bring to the atmosphere. These values here, these are different scenarios, different greenhouse scenarios. What is interesting here is this 4.5, 7.0, 8.5. 4.5 basically tells us that radiative disequilibrium that I was telling you before, that you saw that because right now, because of the carbon dioxide, we have 2.5 watts per square meter additional. Right now, it's already 2.5 plus something else. It's about close to 3 watts per square meter. So if we end up reaching 4.5 watts per square meter, this is going to be the scenario, the yellowish line. If it's this 7 watts per square meter, it's going to be the red. And this other one is going to be even further. So the scenario will depend on how much gases we put into the atmosphere, because that's going to drive this radiative disequilibrium in the number of watts per square meter that are incorporated in the Earth system, and the Earth has to warm because there's no other way. The problem here is that even if we were able nowadays, to change our style of life and say, okay, let's not introduce 1 single gram of carbon into the atmosphere any further. Let's stop introducing and let's go back to pre-industrial times. The problem is that all gases, but particularly carbon, has a residence time in the atmosphere between 50 and 100 years. So even if we cut everything right now, we still will have another 50, 100 years incorporating this additional 7 watts per meter square. All this is going to go into warming the planet. Here are a very simple calculations using radiative models. For example, here you see that goes to 2,500. Imagine that we were able to stop everything at year 2100. So cumulative emissions of CO2 will increase, and then year 2100, they stop. No more emissions of CO2 into the atmosphere. What's going to happen with atmospheric CO2? It's going to keep increasing until year 2100, but then will decrease slowly because of this residence time in the atmosphere. And what's going to happen? Well, ocean temperature, well, let's look at global mean temperature will increase rapidly till year 2100, and then will keep increasing slowly, but still will keep increasing. Despite we are not introducing any more gases into the atmosphere, it will keep increasing and will stay there because of this long residence time. And the temperature of the ocean will increase, but will keep increasing. You see, it's increased very little, 0.1 degrees, and will go into 0.7, 0.8 degrees, but will keep increasing further because that's where this additional heat is going to go. And the danger here is that this is the change in sea level by year 2100. It's estimated that sea level will rise by about 1 meter, but by year 2300, again, depending on this emission scenario, the sea level may change between 3 and 15 years. And everything will depend on how Antarctica continent behaves, because that's where most of the ice is, the continental ice is being retained. Right now, Antarctica is behaving very well. It's basically not losing ice, winning and losing some ice in some other places because it's a continent that is isolated by the Southern Ocean, very well isolated, but we don't know what's going to happen. So this is really a danger. Last section. Okay, let's take this as an opportunity. Okay, opportunity is because both bottom-up and top-down, there's a sensibilization that the Earth is finite and that we have to change. It's like when you get very sick, you have a cancer and something terminal, or you say, okay, either I change my style of life or I'm gone. So you have you really bring this consciousness and you change your style of life. And there are opportunities there. And for the first time, we have realized these opportunities. The possibility is, okay, let's go into a new revolution. Let's call this the collaborative revolution. And why is collaborative? Because both top-down, all this, the Declaration of Harmony with Nature in 2009, and then Sustainable Development Goals, the Ocean Conference, and then the Ocean Decade, and the EU Mission Restore Our Oceans and Waters, are top-down initiatives with the Green Deal, all this recuperation money that is really invested, and let's take this opportunity. But also, what is happening here is an example, this bottom-up pressure that we are changing and joining forces, collaborating, and changing our style. So very few words. Okay, sustainable development. I know there are many interpretations, but I love this one. Sorry, sustainable comes from substenere, is to hold from the base, take care, no? And development is something like depth envelope, no? Something in your inside your envelope that it's an inner potential that you develop, you unfold it. No? So let's feel that you rather than this utilitarian perspective of the planet, let's feel as part of the planet and release this inner potential. And this then comes this idea of the collaborative revolution. But the collaborative revolution to be really effective, and that's why it comes ours, in my opinion, is you have to mobilize people. No? And people, you mobilize it by a combination of things. You cannot mobilize people cognitively. No? Cognitive is okay, but it's not enough. If children, they know climate change, but they don't change attitudes, and we know, and we don't change attitudes. So you have to combine this cognition with this sensoriality, with with this experience, continued experience in time. And when you put these two things together, then come about this wonderful word, sentiments. Sent, which are senses, and mind, sentiment. It's the conjunction of senses and minds that brings about this powerful and motivating transformative. No? So this is basically what here, and I'll go very, very quick on this. Fluid brain. Okay, we are much more than a cognitive brain. We are sensoriality and emotion and history, and that connects us with everything. And life as a process. Okay, we are not individual, disconnected. We are. I'm me now, but in a second, part of me is going to be breathed by you, and so let's take this as an interconnection with nature, but also among all people. No, that's a key point. We are all interconnected, and here comes a very interesting idea that actually he's not here, but Jadon at some point, Jadon Rowan brought me this, and I started reading about this, and I thought it's fascinating. No, an action. No, it's environmental action. No, so the environment that you perceive is the way you interact with this environment. We are right now perceiving this environment because we interact with this environment with our senses, with our cognition, but what's really happening here, we don't know. We don't know. It might be full of spirits, full of many things in this, and the earth, obviously. So let's try to empower our experiencing of nature so that we are more connected with this nature, and we interconnect with each of us as an opportunity to perceive that we are not isolated, and then try to drive all this into a transformative society. No? This is basically the idea. No? Let's try to go into this direction. No? And again, I think that art is the only way to make these connections, to make this emblument, no? that with the ocean as the essential and central part of our living planet. It's for me as an oceanographer, the ocean is an opportunity to bring this evolution, individual, collective, and as a species of the Homo sapiens. Homo sapiens, where we want it to go. We want it to go into a more technology and compete with machines. That makes no sense. That's senseless. No? Machines are already overpassing us. But rather, we want to bring a more senseful, even sensorial, more sensitive individual and collective and species. No? I love this guy. You have to read these guys. This guy, José Tolentino Mendoza, has a number of essays that are wonderful, and he's a cardinal. I didn't know when I read his first book, but he emphasizes, it's like our Jordi Llimona. You know Jordi Llimona, some of you may remember, he's a guy from the 70s and the 80s from Catalonia, and they emphasize the importance of sensoriality, of being humans, and all these elements that interconnect us. And this guy tells us about the science of happiness, and then you have this collaboration rather than adding multiplies. We know about this. No? You've been talking about this morning. But I like to finish with this message. No? It's an opportunity, but not only opportunity to overcome global change, but also opportunity for Homo sapiens to evolve as a species towards these values, the true values. No? These empathy, sensibility, trust, hope, joy, love, all these values that should be what drives us. No? So these are the ideas I wanted to share. These are probably a little bit beyond, but the feeling of the ocean as interconnecting each of us. So, well, these are take-home messages. I'll skip them. Thank you very much.